All right. Thanks so much, Steve, for that intro. And thank you, everyone, for joining me tonight. Really excited to share a little bit about the chemistry of wine with everyone. I guess a couple caveats that I have to give before we get started. I, of course, designed the talk for a pretty general audience, certainly an audience that knows very little about chemistry and probably not much about the world of wine as well. And hopefully it'll be pretty accessible to that group of people. At the same time, I know we have a handful of folks joining us, including at least two alums from the chemistry of wine class that I saw trying to thumb through the little pages on Zoom of who's attending here, Austin Shivington and Alex Pittsford. So I guess for folks that are experts in chemistry or wine or both, hopefully there'll still be little nuggets that they can find, a few nuggets they can find interesting, or maybe just quiz time for the alums. I don't know, maybe we'll put them on the spot. But anyway, go ahead and open those bottles if you haven't done so. It sounded like when everyone logged on, I heard a lot of glug, glug, glug of wine bottles. So I think people are ahead of me on that one. But feel free to go ahead and pour the wines and let's kind of get organized for the tasting here. And I think I actually need to take a second and minimize Zoom. There we go. Then I can see my whole slide as well. So yeah, Steve, if you could monitor the chat, and if there's anything real pressing, just feel free to interrupt me and speak up because I can't. I don't have the chat visible. I have the slides up. But yeah, let's kind of get organized for the tasting here. So we'll just kind of go ahead and pour our four wines, and just for the sake of clarity with talking about different concepts, we'll go ahead and have on our far left wine one. And so this is our Chablis, our Domaine Pinson. And I was actually informed by the shop that they sold out of this wine. And I found that out when I went to go and get it myself this past weekend. So some of you might have a substitute. I have a William Febvre Chablis, but any Chablis should do fine for what we're talking about tonight. So that's wine one. Wine two is our Chardonnay from California, our Splendeur of the Sun. Here again, kind of a little asterisk. I believe a lot of you have the 2018, but some of you may have the 2019. That's okay. That's going to be a wine that is generally made pretty similar from year to year. Wine three, we're going to have our Bordeaux, our Chateau Blaignan. And then wine four is going to be our Substance Cabernet Sauvignon from Washington State. And so I'll just kind of, for the sake of brevity, I'll often refer to those by their numerical identifier, if you will, wine one, wine three, wine four, rather than the name of the actual wine. But anytime we kind of get to comparing something, I'm just going to put this little graphic back up on the bottom of the slide. And, you can just kind of keep them in that order in front of you, and then they don't get mixed up. And as we go, there'll be some specific concepts that we'll go back to the wines and I'll say, oh, can you taste this or smell that or detect that? But just kind of as we go, feel free to be smelling those wines and tasting those wines, and just kind of hold in your mind any flavors or aromas that you can identify, or feel free to jot things down if you like. And then you can just kind of compare, your impressions over the course of the evening with some of the stuff we learn about. And on that note, just a quick discussion of kind of proper tasting. Again, my apologies for some of the folks in the virtual room here for whom this is old news. But if you've never really done a real critical or intentional tasting of wine before, you always just kind of want to first look at the wine, note the color. It can be particularly interesting to note any color differences between similar wines. So maybe among our two whites or our two reds, are the colors real similar? Are they a little different? Next, you want to give that glass a swirl and smell. And the easiest way to do this, if you're not practiced, is just kind of hold the wine on the tabletop, keep the base of the wine on the table and just kind of swirl it in a circle. And then get your nose in there and see if you can identify any aromas that could range from fruit or sort of herbaceous or vegetal aromas to kind of earthy smells or any number of other aromas. Then, of course, we can go ahead and taste the wine. We can note flavors, again, fruit, a lot of other different flavors you might get too, but also concepts like acidity and astringency that we'll talk about tonight. And then, of course, it's always good to just kind of take a second and think about the wine. If there's something you really liked about it, what was that specifically? Alternatively, if there was something you really didn't like at all, what might that be specifically? And so just a little primer on good wine tasting there. So we'll just kind of, with that, jump into the chemistry. So what is wine from a chemistry perspective? Well, on some level, one could argue that it's not particularly interesting because it's 86% water, right? 86% of roughly speaking, of what's in that glass in front of you is just water. And then, of course, the next highest fraction is alcohol at 11%. And a quick side note, if anyone, it's the numbers are looking weird and, oh, I see on the bottle that it's 14% alcohol. Is that just different than average? Is it normally 11? No. This table here, minor point, is organized by mass, and the number on the bottom is alcohol by volume, right? And of course, ethanol or alcohol has a different density than water. So that's the main discrepancy that you're seeing there. But by mass, wine is mostly water and alcohol, and then everything else is less than 3% by mass of what's in the glass in front of you. And so on some level, perhaps jokingly, we can say, well, this isn't very interesting because it's basically just a dilute solution of ethanol, right? But I think a lot of chemists would look at this and say, well, how astounding that across wines and the whole myriad of diverse styles that they come in, the many flavors and aromas you can detect, how remarkable that just 3% or less of what's in the glass is responsible for the entirety of that diversity. And a very, very interesting thing to think about chemically. So kind of delving into that 3%, what is it made up of? Well, of course, within that 3%, it's just an incredibly complex solution containing a wide variety of compounds, and they're going to affect the aroma, the taste, the mouthfeel, the color, and just the overall character of the wine. Breaking it down further, these major components can include organic acids, and a lot of these kind of major classes, if you will, we'll talk about tonight. They can include organic acids, residual sugars that aren't fermented into alcohol during the fermentation in some wines, pigment compounds, so whatever gives a wine its color, tannin, we'll certainly talk about tonight. These are responsible for astringency in wine. A compound called glycerol that is not particularly interesting from a taste or aroma standpoint, but is a rather large percentage of the 3% by mass. And then, of course, a whole slew of organic compounds responsible for particular tastes and aromas. And it's sort of worth noting, in a similar theme to the previous slide, the organic acids and the glycerol, so these kind of two classes of chemical compounds here, the acids and the glycerol, are responsible for a rather large fraction of this 3% that we're talking about. So really, when you're talking about what makes wine different, and also what makes wine pleasurable or enjoyable, you're talking about far, far less than this 3%, because if, again, the majority of it are organic acids and glycerol, and of course, if you just had a solution of water, alcohol, some organic acid and glycerol, it wouldn't be remotely really palatable or particularly enjoyable at all. And so how astounding that such a diversity can come from such a small amount of what's in front of you. And so I'd also like to talk real quick about where these compounds come from. So there's three main sources that all of these compounds can come from. First, of course, is just the grapes themselves. So the organic acids that are in there, the sugars, tannins, those pigments or color compounds, as well as select flavor and aroma compounds. These are all present in the grape as it's there on the vine. And of course, they kind of remain intact and end up in the bottle and in the glass. However, a lot of compounds either undergo a lot of chemistry that kind of changes their structure and therefore their aroma and taste, or new compounds that have distinct aromas and tastes are synthesized via fermentation. So kind of editing of compounds that were there, as well as creation of new compounds, will happen during fermentation. Lastly, there's maturation and aging. So this is referring to a wine maturing and aging, maturation. So here, important concepts are the impact of oak. A lot of wine is stored in oak barrels, which we'll talk a little bit about tonight. And that imparts unique flavors and aromas and other characteristics to the wine. But then there's also some really interesting chemistry as regards aging. And so, certainly culturally, it's well known that at least fine wines, right, tend to get better with age. And there's some interesting chemistry we can discuss there. As a side note that I always like to tell people about if they're kind of new to the world of wine, the vast majority of wine produced in the United States is really not meant to be aged. I remember when I was first kind of getting into wine in graduate school, I thought that I could go buy any red wine from the grocery store, and maybe if I hang on to it for 3 years or 4 years or something, it'll get better, right? And that's really not the case. Most wine produced in the United States is designed to be consumed within like 6 months to a year of it hitting the shelf. But of course, in the world of fine wine, they do really get better with age and, of course, proper storage. But that's not something we really have time to talk much about tonight. A couple other terms real quick. So wine chemists like to call these compounds that are present all the way from the grape itself into the glass primary compounds. They're there the whole time. New compounds that come up as a result of fermentation are called secondary compounds. And then flavor or aroma compounds that appear just during maturation and aging are called tertiary compounds. And so those are the names for these kind of three different classes or sources of chemicals. And one interesting graphic that I like to show that kind of showcases secondary compounds and their genesis is this figure right here. So, of course, well, a couple pet peeves here, like I'd yell at my students for, we have no title on this plot, right? And some other criticisms that I would give it. But I can explain it to everyone here. No need to be intimidated. So this is simply two results here. We have a plot on top and a plot on bottom. And this is a result of a GCMS experiment for anyone curious. That's gas chromatography mass spectrometry. But what they did is they took a sample of grape juice before it's been fermented and ran it through the GCMS. And what this plot is showing is that every peak you can see, and I'm hoping my cursor shows up on the screen here, every peak you can see in this trace is a unique chemical compound. And so you can see even in grape juice, we have a decent number of different peaks spread out in time here. Each of those is a unique chemical compound present in the sample. Well, the bottom trace is that exact same sample of grape juice run again on the GCMS, but after it's been fermented into wine. And of course, you can see that the number of peaks here in this trace just explodes, including some areas where there's probably so many that they can't even all be resolved. So this illustrates really well just that diversity of flavor and aroma compounds that come from the fermentation process. So we'll go ahead and move into kind of our first class of compounds I'd like to talk about, and these are the organic acids. Not only are these a large mass fraction of that 3% that I talked about earlier, but they're very critical to the character of a wine and its mouthfeel. So the most common organic acid is tartaric acid. And hopefully the non-chemists in the virtual room here can forgive me. It feels wrong to not show chemical structures tonight. But if you don't really know at all what this structure means, that's just fine. In fact, you can pretty much just ignore it if you want to. But for anyone interested, this is just a skeletal notation that we use for organic compounds. Basically, anywhere there's a junction in these little lines, it just means there's a carbon atom. Of course, carbon, right? This is the atom of organic chemistry. And rather than drawing it a million times, we just kind of like to use these lines as a shorthand. But this is a compound tartaric acid here. In food overall, wine grapes are a major source of tartaric acid, though it can also be found in bananas to some extent. Another common acid in wine is malic acid. And this is what gives things like Granny Smith apples and rhubarb their kind of bite or sourness. And you can kind of picture that maybe mouth puckering sensation that you get on the sides of your tongue. Malic acid is really common. And then interestingly, a lot of wines actually undergo what's called malolactic fermentation. So this is separate from the fermentation that turns sugar into alcohol. And this usually happens when and if the wine is stored in an oak barrel. But certain bacteria will break malic acid down into lactic acid, which you can see right here. And lactic acid is what gives items like yogurt its kind of tang. And it's also present in sourdough bread. And so this kind of often mellows a wine, and you can kind of picture the difference in the bite of a Granny Smith apple versus just like the tang of yogurt. That's the malic acid to lactic acid difference. And of course, with all of these acids, you might be wondering, what is the pH of wine? Obviously, a metric that I think is pretty well known just beyond the chemistry classroom. The pH of wine tends to lie between 3 and 4, often about 3.5. though it can creep up into the low 4s in some wines. And we'll talk here about the trend with acid and grape ripeness. So the way this works is that as those grapes form on the vine and ripen, and we just have an image here of all grapes, regardless of varietal, start off kind of more that green color, but then will only develop their color as they ripen based on the varietal, right? Of course, not all grapes take on that color. But anyway, as the grape is less ripe, there's an awful lot of acid present. And then as it ripens, that acid breaks down and goes away. And of course, and currently, like what happens when any fruit ripens, is that the concentration of sugar increases as the grape ripens. And so what you'll find is that highly dependent on the climate that the grape is in, but also the style that the winemaker is going for, you'll get wines that are higher or lower in acid, just depending on when they picked the grapes. And so we'll go ahead and move to our wines here and kind of do our first aspect of the tasting. So again, we recognize acidity on the sides of our tongue. You can picture that sort of puckering feeling or sour sensation in things like a Granny Smith apple or rhubarb. And what I'd like everyone to do is go ahead and compare wine 1 against wine 2. So the 2 Chardonnays there. And then separately taste wines 3 and 4 and compare them with each other. And among each pair, so between the 2 whites and between the 2 reds, see which one seems to have higher acidity. And so I'll just kind of go ahead and give us maybe, I don't know, 60 seconds or so to taste those wines, particularly if you're watching with, friends or family members. We'll give everyone a chance to try them and maybe discuss a little bit. Okay, it's been about a minute. Feel free to keep discussing, but I'll go ahead and forge ahead just for the sake of time here. And so let's see. There we go. So we'll come back to this acid concept and talk a little bit more about wines, but we'll kind of go ahead and do a quick detour here en route to coming back to these ideas. And rather than chemistry and chemical compounds, we'll learn a little bit about the world of wine. So you'll often hear the terms old world and new world thrown around. This is pretty easy. And these terms can refer to both the climate of a region, but also the style of the wine. And that'll be kind of a theme for the rest of the talk tonight. But when people say old world, they mean Europe. And the style of wine typically, or at least historically, made in Europe. And when people say new world, they're referring to basically everywhere else that isn't Europe. And so we can talk a little bit about the specific regions that our wines are from tonight. And the theme that we'll keep in mind here is that generally old world wines come from cooler climates and are made at least in a style that kind of goes for a cooler climate. So maybe picking the grapes a little earlier than they otherwise would in the New World. And then as I kind of just said, so New World, generally warmer climate, or even if it's a slightly cooler climate, winemakers might wait a little longer to pick the grapes. And so the general trend is that old world wines are higher in acid and new world wines are lower in acid. Now, of course, you can find producers doing the opposite. Everywhere there's producers in California making very old world style wines. There's producers in Southern France making very new world style wines. So obviously it's just a general rule and there's plenty of exceptions. But we'll just kind of explore these regions here. So wine 1, our Chablis, is from this, again, Chablis region in France. That's part of Burgundy. And I'll discuss a few more details about each region on the next slide. Whereas wine 2 is from the central coast of California, an area called Monterey. And indeed, Monterey does have a slightly higher or a slightly warmer climate than Chablis. And so I can go ahead and say what I think here, not to bias anyone's opinion too much. But I certainly think between wines 1 and 2, I get more of that kind of tingling on the sides of my tongue in wine 1 versus wine 2. I think wine 2 is a relatively low acid wine. And so this is really, in this case, just a direct result of primarily the climate, but also a little bit of the winemaking style between these two particular producers. Wine 3 is from Bordeaux. So we're back in France there on the left, kind of southwestern France, and specifically an area of Bordeaux, a subregion called the Médoc. And wine 4 is from Washington State. It just comes from the Columbia Valley, and that is as you can see on the map, a rather huge wine growing region in Washington. No kind of sub-appellation or sub-region is indicated, and so it probably means that the grapes come from all over the Columbia Valley. And between wines 3 and 4, I think this is a little more difficult. Wine 4 is a very full-bodied wine and has some intense flavors that kind of hit me right on the center of my tongue. But if I try to really hone in on just what's going on the sides of my tongue, I do think wine 3, our old world wine, is a little bit higher in acid than wine 4. A little bit more detail about each of these regions. So if you're new to the world of wine, if you just study a little bit, you'll see that certain varietals do best in certain climates. And indeed, after this was sort of noted historically, and fine wines of particular varietals came from distinct regions, now there's actually, primarily in the old world, a lot of regulations and laws about what varietals can be grown where, and what the wines grown from those grapes can even be called to be from a certain place. So I probably won't describe that more, but certainly something that you can find out more about if you're interested. But in Chablis, this is part of Burgundy in France, which is probably one of the two most famous wine growing regions in the world. In Burgundy overall, there's Pinot Noir and Chardonnay planted. In Chablis, it's 100% Chardonnay. On the Central Coast, moving to the New World here for wine 2, Monterey, again, as I just said, part of the Central Coast. So this is south of the more famous region, Napa Valley and Sonoma, which are the quote unquote North Coast. Monterey is famous for a number of varietals, but it's best known for Pinot Noir, Chardonnay, and also Syrah, which, if anyone's curious, that's the same thing as Shiraz. It's often labeled that in places like Australia. Wine 3, again, is from Bordeaux. This is the second most famous wine growing region in the world. And there's plenty of good white wine made in Bordeaux, but it's, of course, most famous for its reds. They tend to be blends of the 5 noble grapes of Bordeaux, primarily Cabernet Sauvignon, Merlot, and Cabernet Franc, though they can often contain varietals of Malbec and Petit Verdot as well. If you remember on that little map on the previous slide, there's regions of Bordeaux kind of on both sides of a large river. Wines from the left bank are Cabernet Sauvignon heavy. Again, they're often blends with multiple of these varietals, but you tend to have a higher proportion of Cabernet Sauvignon if they come from the left bank, and a higher proportion of Merlot if they come from the right bank. And indeed, if anyone has the bottle handy, you can look at our Chateau Blaignan and see that it is from the left bank, from the Médoc. It is 55% Cabernet Sauvignon and 45% Merlot. And then finally, Columbia Valley up in Washington. It's Washington's largest wine region. It really spans a number of different microclimates, so you can get a real tremendous diversity of varietals grown there. But it's best known for Cabernet, Merlot, Riesling, and Chardonnay. So kind of with that, move on to our next subclass of chemicals here. And so we'll talk a little bit about sugar, alcohol, and fermentation. And so I think most people are probably familiar with the concept that in general with fermented beverages, sugar is turned into alcohol, right? And so the primary sugars present in wine that undergo fermentation are glucose and fructose. They're sugars, you can see both of them have 6 carbons in there, so they're known as hexoses. And yeast, typically Saccharomyces cerevisiae, converts these hexoses to alcohol via the following reaction. And so you can see we have sugar as a reactant on the left, and then ethanol as a product on the right. And of course, we also get CO2. And so this is why when anything ferments, you often see those bubbles coming out of solution, right? That's the carbon dioxide. And for any folks that maybe have a biology or medical background, I had to include our full reaction here, right? And so we have some energy considerations with ADP and ATP. If you want to ignore that and just enjoy the wine, that's just fine. And of course, we should say that not all wines are fermented to dryness. So don't let this reaction make you think that all of the sugar is always converted entirely into alcohol. Sometimes it pretty much is. And in plenty of other wines, it isn't. Probably most notably, Rieslings from places like Germany and the Alsace region of France. Fermentation is intentionally arrested or stopped before all that sugar has turned into alcohol. And so you have sweet wines. Of course, dessert wines in general as a category are sweet, right? And that's key to that process, is not fermenting the wine to dryness. So here again, looking at kind of trends as ripening happens, of course, it makes sense that we have very little sugar when the grapes are not very ripe, and then the amount of sugar increasing as the grape ripens. And so, of course, what this correlates to is a lower maximum final alcohol level possible when grapes are picked slightly less ripe, and a higher maximum alcohol level possible when grapes are picked when they're a little bit more ripe. Of course, assuming that they are actually fermented to dryness, as is commonly done. Okay, and so we'll go ahead and move on here to talking about tannins. So this is probably the area that if anyone joining is a wine expert or has a decent knowledge of chemistry coming in, hopefully this will be pretty interesting to you. Hopefully still accessible to the whole audience as well. So tannins are interesting to talk about from a chemical perspective, because tannin is not a chemical term, but actually refers to just a broad class of compounds that have the ability to tan animal hide into leather historically. And far from only being present in wine, they're present in a lot of food and really plant matter overall. So tea is full of tannins, particularly black tea. Chocolate has tannins. And even general, wood products and bark, there's amongst the myriad of organic compounds that make up those materials, there's a lot of tannins present. So chemically, if we have to identify tannins, we would have to call them polymeric polyphenols, which might sound like kind of a mouthful, but hopefully we can break this term down a little bit here. So I'll go ahead and show some structures, and we'll just kind of talk about what this name means. So again, we just have a lot of carbon atoms, right? And they're kind of forming all these rings and these different compounds here. You can see among these 5 compounds that they're very similar, right? They just kind of vary in the exact arrangement of some of these atoms in space and where exactly some are connected to others. But phenol, we'll just kind of focus on that term for a second. Phenol, that's a chemist term for when you have a ring that looks like this right here, where we have a carbon ring in these kind of alternating double and single bonds that you can see. And then we have this little OH or hydroxyl group attached to that ring. So that collective moiety, that ring with the little OH attached, is a phenol. And you can see here, going back to this name, polyphenols, well, that looks to me like it describes these compounds quite well, because we have multiple rings, each with multiple OH groups attached to them. So poly, many, we have many phenols in these compounds. And then polymeric or polymer. This is probably a term that more people have heard before, especially in today's day and age. This just comes from the Greek for many units, right? And so tannins, they're polymeric polyphenols. What tannins are is we're going to take these individual building blocks right here and just connect them together to form a really long chain or polymer. So these are monomers of our larger polymer. And so you can see a couple example structures here. Don't worry about any of these specific names, these procyanidin stuff. That's beyond the scope of what we'll talk about tonight. But you can see these monomers can come together in any number of different ways to eventually build up long chains, like you can see on the right here. And this long chain of these individual building blocks, this polymeric polyphenol, is a tannin. And tannins are responsible for the astringency of wine. And we have to be careful about our terms here. So astringency is the proper term for when you consume something, again, often wine, but it could also be like chocolate or tea, and you get that kind of drying out sensation in your tongue or in your lips. And what's happening there is that there's proteins in your saliva that are actually being precipitated out of solution by the tannins. The tannins kind of grab onto them and cause them to crash out of solution, and that gives you that dry mouth feeling. Wines, of course, you've probably heard also described as dry, but that term really more properly refers to just a wine that has no residual sugar. in it. And so basically calling a wine dry just means that it isn't sweet, or you can think of it as the opposite of sweet in a wine tasting context. But astringency is the proper term for tannin, though yes, they do cause a drying out sensation in the tongue or the lips. And so some really interesting chemistry that we can talk about here. So tannins are these big polymers, right, made up of the individual polyphenol units. Well, that big polymer tends to break down over time. So this is as the wine is sitting in a bottle, and maybe if you let it sit for a decade or two. Well, it turns out that as those polymer chains break down and you go from, say, one really, really long chain molecule to a larger number of shorter chain molecules, their ability to precipitate those proteins in your saliva, their ability to cause that astringency sensation decreases. Okay, so as a wine ages, it becomes perceived as less astringent. And there's a great plot here that kind of showcases this very cool experiment. So what's going on here was that a certain wine that's just made by a certain producer from, a certain vineyard every year, right? They take the same vines, harvest them year after year, make all these different vintages. That wine was tasted by a trained panel. And of course, they got to taste a lot of wine, right? Because we have a whole lot of different vintages here that they sat down and tasted during this experiment. Well, the tasters were also asked to score the astringency of the wine just on a numerical scale from 0 to 5, 5 being very astringent. You get a lot of that mouth drying feeling, and 0 being, no astringency detected. So you can see here that on the top trace, this is the panel score. They scored all the youngest wines as the most astringent, and then the oldest wines as the least astringent. Of course, there's a lot of variation. And of course, the top plot here, this is going to have just taster variability affecting the data. It's going to have vintage to vintage variance in the actual grapes and wine affecting the data, right? But we can certainly see a trend overall where younger wines are perceived as more astringent. Separately, those same exact wines were subjected to some experiments where the tannins, those polymeric polyphenols, were quantified chemically, and you can see a similar trend there, though still, of course, with some vintage to vintage variation in the data. But again, we see that correlation between the two here this time of increased astringency for younger wines. There's also some interesting chemistry when it comes to tannins and their interaction with wine pigments. And really here for reasons we'll talk about shortly, we're just talking about red wines. But our pigment compounds, what gives a red wine its color, the fancy term is an anthocyanin for those pigments. If anyone else is like me and likes knowing the root of words, right, cyan often refers to blue. That's because these compounds absorb in the blue region of the spectrum, which in fact makes them appear red to our eyes. So that's a little bit of where that name comes from. It turns out that these anthocyanins, these pigment compounds, and there's an example one shown on the right there, are rather unstable and would tend to break down quite quickly over time if just left kind of floating around on their own in wine. But it turns out what happens, and you can probably see this just looking at the structure here, we can see a lot of this looks quite similar to those monomers of the tannins that I showed on the previous slide, right? We have kind of these 3 rings with that oxygen in the middle there, except when you get a glucose molecule, that's the same sugar we saw earlier, it's glucose. When you get a glucose bonded to this compound, it gives it a color, and it becomes a pigment rather than a monomer for a tannin. However, because of its similarity, it can behave in a similar fashion, and you can actually get what are called stabilized wine pigments, where you have here's just a section shown, but a tannin compound, right, a chain of these monomers. But you can see, as evidenced by the little glucose group I've circled in red right here, this is actually a stabilized wine pigment because one of our little monomers of our tannin has been replaced by an anthocyanin, or a pigment compound. And so this is really the only reason that red wine will retain its color beyond, maybe a couple months in the bottle. Of course, they do still break down slowly over time. And if you've ever had a wine that's a couple decades old, you've seen that it really loses that kind of intense, ruby or red color, and will usually become kind of go through a garnet or kind of brick red stage, and eventually will sort of just become brown as those compounds do break down overall. So we can go back to our wines here and talk a little bit about tannin. So the biggest thing here is that tannins are present in the skin of the grape and also in seeds. in the stems as well, though it's not always common that the stems really have any contact with the wine itself, though that is done in some areas with some varietals. But anyway, the difference in winemaking here between whites and reds is crucial. When a white wine is made, the grapes are pressed and the juice is separated from the skin and the seeds and everything else, and then undergoes fermentation. And that juice, all during fermentation and for the whole rest of the process, never has any contact with the skin or the seeds of the grape. Whereas in red wine, the grapes are usually lightly crushed to extract some of the juice, but then kind of the whole vat of everything is fermented. So you have a big vat that contains a lot of juice, but also grape skins, grape seeds, sometimes even stems are included in there as well. And so for the 10 days to 14 days of fermentation, that juice is in contact with the skin and the seeds, and it can extract not only the color compounds, of course, but those tannin compounds as well. So accordingly, when you taste your wines here, you should perceive none of that astringency or that mouth drying sensation in the whites, but I think it is discernible in both of the reds. We certainly have some tannins present in both of our red wines. And so again, I'll just give everyone another 60 seconds or so to kind of go back to those wines and hone in on that astringency sensation and see what you think. Okay, so we'll go ahead and move forward here. So one of the last topics I want to talk about is wine and oak. So just historically, barrels made from oak were found to be a more rugged and lightweight option for wine storage versus maybe the clay amphorae that might have been used in the ancient world. And this is simply because, oak barrels, not only were they lighter than clay pound for pound, but they could be broken down into their staves and stored when they're not in use. And of course, as it says, much less fragile as well. But then, of course, presumably about the moment that this was tried, it was discovered that it has a positive sensory effect on the wine. And so it was sort of a match made in heaven, so to speak. And I have just a nice photo here of one of the wineries that we get to visit on the trip, on our immersion trip out to California. This is O'Shaughnessy Estate Winery out on Howell Mountain. And of course, this is owned by trustee Paul Woles and his wife, Betty O'Shaughnessy Woles. So oak has some very interesting chemistry going on. When these barrels are constructed, and you can see in the photo here, basically when the staves or the sides are constructed, but before the top and bottom go on here, they're subjected to heat, either a fire or modern times, sometimes just an infrared high energy or a high intensity infrared source. Anyway, the barrels are heated and actually toasted. So you get some color on the inside of the wood. It isn't really burned, certainly not charred like you might find in a whiskey barrel or something like that, but the oak is toasted. And what that does is that breaks down a compound in oak called lignin into a lot of different kind of interesting flavor and aroma compounds. So one common breakdown product from lignin is oak lactone, and this is often correlated with aromas of coconut, vanilla, and dark chocolate. There's also the compound vanillin, which of course is going to have the taste and aroma of vanilla. A compound called gamma butyrolactone, and this is correlated with caramel notes. And then finally, compounds like eugenol, which you can notice is another type of phenol. We have that same ring with that same OH group coming off here. Eugenol and related compounds are correlated with clove or cinnamon or nutmeg or these kind of baking spice aromas. And an important principle here is that new oak, so in other words, a brand new barrel that's never been in contact with wine before, is going to impart a lot of flavor onto wine. There's a lot of these compounds present that the wine can kind of leach out of the barrel for the time it spends maturing in there. But after this is done, maybe 3 to 5 vintages, that oak has kind of donated directly all of the flavor compounds it's going to donate. And so neutral oak really imparts minimal to no flavor on the wine. Aging in neutral oak still really affects the character and overall profile of the wine, but this is more related to reasons of little bits of oxygen getting in there, kind of the barrel breathing, and chemistry going on as a result of little bits of oxygen being introduced rather than compounds being donated from the oak themselves directly to the wine. And so I think this works out pretty well for our tasting tonight, looking at oak. So what I'd like everyone to do is first hone in on wines 1 and 2. And before I reveal anything, just kind of taste the 2 whites side by side and see if you can detect any baking spices, both on the nose and on the palate. Perhaps sometimes even the aroma of oak itself. I've found kind of an interesting diversity where some wines that have a lot of treatment in new oak, they have a lot of that baking spice aroma, if it's French oak anyway. And some of them, it smells like I'm in my dad's workshop when he's making a piece of furniture. It just kind of smells like oak itself. Vanilla is, of course, also another common aroma associated with oak. So we've had a decent amount of time trying our wines tonight. I'll give just a few seconds to try wines 1 and 2 next to each other again, and see if one has kind of more discernible oak character as described on there. So I've intentionally tried to not bias the virtual room here with too much of my own opinions tonight, but certainly when it comes to wine 1 and wine 2, I think the oak characteristics are very discernible on wine 2, particularly on the palate. I taste a lot of cinnamon or sort of spice notes, as well as we'll talk about fruit aromas before we end here in just a slide or two, but fair amount of baked apples. So wine 2 is really kind of like apple pie to me, or something on the palate. Certainly a lot of the baking spice aromas and flavors, in my opinion. And it turns out wine 1 had some aging in neutral oak, as is common in Chablis, and wine 2 had a larger percentage of new oak. And in practice, what's done is, winery will often take their entire stock of wine and age some of it in new oak barrels and age some of it in slightly older barrels and some in neutral barrels, and then end up doing a final blend of everything before it's actually sent out as a commercial product. You can also taste wines 3 and 4, and both of these wines saw time in new oak. And so just kind of as we go on tonight, you can give them a sip and see if there's kind of differences discernible in the exact amount of oak, or maybe in the specific character of that oak. We won't have time to discuss this tonight, but you can actually get very different flavors from different types of oak. There's a region in Spain called Rioja that often uses American oak, and that gives a completely different aroma profile than a European or a French oak, though both our Cabernets tonight were aged or matured in European oak. And so lastly here, I just kind of want to provide this potpourri, so to speak, of other kind of example compounds. And so, I want to do this just because in a way, a lot of what we've talked about tonight, our acid, our tannin, these are perceptions that are pretty easy to identify on the palate. But I guess perhaps not the first thing that comes to mind when you think of what might make wines different from each other, right? So maybe the first thing that comes to mind is just, well, one smells like peaches and one smells like blackberry, right? And so we can talk a little bit about some of these other organic compounds that give rise to these aromas. I'd really like to hone in first on our methoxypyrazine compound here. So this has the aroma and taste of bell pepper, like a green bell pepper. And this is really common in Bordeaux varietals. And so I'd also encourage you to go back to wines 3 and 4 and see if you can detect any of that bell pepper aroma or taste on our Cabernets tonight. Diacetyl is the quote unquote buttered popcorn compound. It basically smells and tastes like butter. And I didn't pick up on a ton of that this evening, but often California Chardonnays are kind of famous for having some of that butter compound there. A lot of other compounds that give rise to typical fruit flavors. So isobutyl acetate here is banana oil. That's a classic banana flavor. Limonene is present in lemons and citrus, but it's also can be present in certain varietals of wine, and so you get a lemon aroma. One of my favorites here, this mercaptohexanol compound, this has a very tropical, like a grapefruit or passion fruit aroma. And I sort of laughed when I first learned about this because this has got to be one of the only sulfur containing compounds in all of organic chemistry that actually smells good. If anyone took organic chemistry in their life, you might know that often sulfur containing compounds smell terrible, right? We have another lactone here that tends to give a peach aroma. Berry aromas come from compounds like ethyl isovarilate and beta ionone. And then we have ethyl butanoate, which is one among many compounds that have kind of an apple aroma and flavor. And so just kind of looking at the set here, I'd like to talk about some themes related to Old World and New World, and also the evolution over time. So again, there's many exceptions, but the general rule is that in Old World wines, you're going to have kind of not as much fruit flavors, but maybe more vegetal aromas and flavors, like our methoxypyrazine here, exemplified in the wine, whereas in the New World, they're going to tend to be a lot more fruit forward. So you might get more of these other compounds. But all of these things are really going to evolve over time. So as the wine ages, and even as it sits in your glass, by the end of the night tonight, you know, they might start kind of smelling a little bit different than they did at the beginning. These compounds, we can smell them really easily because they're volatile, right? It just means they evaporate easily. Well, and they can also break down pretty easily in the bottle. So whether the wine is sitting there for a couple hours or whether it's sitting in the bottle for years, a lot of those fruit characters kind of start to go away, and kind of the earthy or vegetal aromas and flavors remain. So there's just a lot of incredibly diverse set of chemicals here, but then their behavior over time and across different regions of the world is just kind of yields an amazing diversity of different wines. And so I'll just go ahead and end here. We certainly have some time for questions. I wanted about 15 minutes, so I think we're doing okay. But just real quick, some additional resources and entertainment that I'd love to recommend. If there's a particular wine that you enjoyed tonight and you know you'd like to try more like it, I'd encourage you to visit your local wine shop, and you can just go and tell them, oh, I had a cheap Bordeaux, or I had a California Chardonnay, and this is kind of what I tasted, and can you recommend more like it? And they'll be very happy to do that. And of course, next thing you know, you'll be maybe spending more money than you should, and getting all involved in the world of wine. But I highly recommend it overall, of course. Also, the Wine Bible by Karen McNeil and the World Atlas of Wine by Hugh Johnson. These are some great educational resources if you really want to kind of learning a lot more about the world of wine. Winefolly.com is a pretty fun and relatively new little site. If you just have a few minutes, you can go on there and poke around, and they just author a lot of kind of informative little tidbits about varietals and geography and everything you might want to know about the world of wine. I also appreciate that they often show some chemical structures on there, and so they tend to have an emphasis on the chemistry as well. Lastly, I just want to share what got me into wine. It's this really fun little documentary called Somm, and it just follows a group of people as they're preparing for their master sommelier exam, and there's a couple sequels as well. Very well made, well done documentaries, and so they're fun viewing if you're interested. But again, thank you so much. And cheers. And I'd be happy to take any questions or discuss anything we might like.
Can I ask a question?
Please.
This is David Lewis. I live in Indianapolis, traveled to different wine regions, but, and I know that some of our friends on the phone are in Napa, but what is the impact of the fires that they have experienced on wines?
Yeah, that's a great question. So very interestingly, let's see if I can jump back a few slides here. So fires are a huge problem, and not just because they can burn the actual vineyards themselves, right? But because that smoke can end up in the wine. So it's actually compounds that are really similar in structure to eugenol. Back here when we talked about oak, that was responsible for the clove and baking spice aroma. There are other phenols. But they taste and smell like smoke, and they're present in smoke. So those can basically just get into the grapes while they're on the vine and then end up in the wine. And what's particularly frustrating here from a winemaking perspective is that you think that you could just pick the grapes and crush them, and if it smells like smoke, don't use it, right? Oh, it's smoke tainted, throw it out. And if it doesn't smell like smoke, we're okay, right? We can make wine out of it. Well, it turns out that that phenol, that molecule that smells like smoke, can actually also bind with glucose, and that renders it non-volatile, which means you can't smell it. And so when it gets absorbed into the grape berry, it has a tendency to bond with glucose. So you can smell the grapes, you can smell the young wine, and it won't smell like smoke. But then as time goes on, that compound can separate from the glucose, become volatile. And so when the wine is bottled, it smelled great, but then it hits the shelves and people open it and it smells like wildfire. So it's a real problem. And it takes very challenging chemical measurement too to try to figure out if that's happened and what to do about it and see if a vintage can be salvaged.
Thank you.
Hey, Paul, we have a question on chat that might be interesting. It says we are interested in knowing how screw tops compared to corks as stoppers, if there's any relevance to the chemistry.
Yeah, that's a great question. So this is sort of, sorry, I keep jumping around in the slideshow here. I'll just try to leave it on that slide. So yeah, screw tops are becoming more and more common, right? So it was originally all cork and then kind of the use of some synthetic cork and now screw tops. So a lot of people, I guess if they know a little bit about wine, they might kind of take an attitude of like, oh, screw tops, it's not traditional, seems cheap. Like that's probably only low quality wines that are, have a screw top on top of them. Not true. So in terms of actually preserving the wine from oxygen, studies show that screw tops are better than both cork and synthetic cork. Cork, and you can probably imagine just by looking at a cork, right? Over certainly decades of storage, little bits of oxygen can move in and out of that cork, right? Whereas a screw top, that really isn't going to happen. And so one is not necessarily better than the other in terms of quality. It's just what the winemaker is going for. So if you want a wine, whereas it sits in a bottle, you just want no oxygen content at all, you really would probably want to go with a screw top. This is particularly wines that are made to be consumed young. Whereas a wine that's meant to be aged, high quality Bordeaux, or maybe like a Barolo from Italy or something like that, you really want to use a cork because then that will allow for a little bit of oxygen ingress over time, and that facilitates the aging and softening process.
Paul, I'm going to ask another one from chat. Does the type of oak used enhance malolactic fermentation?
Oh yeah, that's a good question. I'm not entirely sure. I don't believe that it would. I think that's just going to be certainly more a function of what bacteria are present. So that's like lactobacillus and enococcus that do malolactic fermentation. And I don't believe that the type of oak impacts that too much. Rather, it's just the time generally spent in oak.
Here's another one on chat. Here's a name I will probably not pronounce correctly. Any comments about the Frederick, is it Brochet or Brochette wine experiments?
Oh my goodness, I can't say that I'm familiar with those. I'll just have to be honest.
Chris, feel free to elaborate.
So it was a set of experiments done by Frederick Brochet from the Bordeaux region in 2001, where he was trying to assess the impact of expectation on wine tasting. And he had a group of like 50 some sommeliers or sommeliers in training. And one of the most striking experiments he did is he had bottles of white wine, same bottles, and one of them he just added red food coloring to. And not one of the 54 students identified it as a white wine when they tasted it blindly.
Yeah. Okay. So I didn't know the name, but I've certainly heard of this experiment before and misidentifying even the color, right? Yeah. So, I mean, wine is a complicated world. There's certainly enough anecdotes and evidence and observed tastings out there that clearly a lot of what I've talked about can be deduced, right? Deductive tasting, and people can be fairly accurate with it. At the same time, it's a huge data set, right? If we're just talking about everyone in history trying wine or evaluating it critically. And so invariably from a big numbers perspective, there's going to be some ridiculous mess ups and some entertainment there, right?
Let's do one more. This is also in the chat. Of the compounds you identified that lend themselves to fruit, aromas, and flavors like butter, grapefruit, etc., can you actually identify them in the wines through chemical experimentation? Or do we just assume those are the compounds present?
Great question. It's a resounding yes. It's very easy with the right chemical instrumentation to identify that specific compound. And of course, then it's also generally correlated with like, you can tell structurally and by the molecular mass and everything that it is that exact compound, but they make some interesting things where you can like, like in a gas chromatograph mass spectrometer, that instrument I talked about at the beginning that showed all those little peaks, right? It can identify what that compound is, but then you can also get like an attachment to that instrument that lets you kind of waft the output, right? And at the same time that the instrument is telling you this compound is coming off the column, you can smell and be like, oh, it smells like blueberries. It smells like banana.
Great, thanks. I said that was the last one, but there are two really quick ones on here in chat. And
Oh, that's just fine.
Hope I didn't miss any. And I think these are quick. Is wine better stored on the side or standing up?
Oh yeah, very important. You need to store wine on the side. At least this is most important if you have a natural cork closure. So the cork really needs to remain in contact with that wine to not dry out. When it dries out, it shrinks, right? And then instead of just like micro oxygenation happening, you can get, it'll become vinegar before you know it, right? Because a whole lot of oxygen will be introduced. So certainly if it has a natural closure, it needs to be stored on its side. If it has a synthetic closure, that's less important, though, of course, practically, right, like on my wine rack in my basement, it's made to hold all the bottles horizontally. So it doesn't matter what type of closure they have. Great,
thank you. And then last one, what impact does water chemistry have on different varieties of wine?
Yeah, could that person elaborate more on what they mean by water chemistry? Are we talking about like maybe different metals or minerals or something, or pH or?
Ed and Sue, if you could.
Yeah, just the level of different chemicals that's prevalent in the region where the wine is grown.
Okay.
Hard water versus soft water. The level of bicarbonate, level of sulfates, chlorides present in the water.
Yeah, absolutely. So it's sort of I guess a bimodal, if that's the right term, answer. There's certain things that are probably not going to affect the wine or fermentation too much. So, water hardness is not of critical importance. It can have a small impact on how rigorous the fermentation is, but basically compounds like that or atoms like that, where they don't have a unique flavor or aroma associated with them, or even if they do in pure water, it's going to tend to be masked really easily by the components of the wine. So of course, every winery is going to go an effort to source water that isn't full of contaminants or something like that. But to a first approximation, it's less important than other factors. And a lot of wineries are also going to be doing things, adding extra components or nutrients for the yeast to make sure that fermentation works well. As far as like sulfur compounds or something that have a very strong aroma, it's certainly of critical importance to make sure that your water source doesn't have any of those present. And bicarbonate or other things that would affect the pH, those tend to really be, the effect of those is minimized just by the level of acid coming from the grapes. And in most wine regions, you're allowed to adjust the acid a little bit to get a good fermentation, and also as you might put it in the final product of the wine. And so if that needs to be adjusted, it could.
Okay, so I know there are a couple unanswered questions. My apologies on the chat. So how about a virtual big round of applause for Dr. Paul Schmitt? Fantastic. I know it's tough, Dr. Schmitt, when you can't actually hear the applause, but it's out there, trust me. Couple things. So we can share. There are a few people who chatted about the slides. We can get the slides if that's all right with you, Dr. Schmitt, and we'll work on that on our end.
That sounds great. Yeah.
Yeah. If you want to share this presentation with anyone, so you'd like a copy of the recording, what we will do is take this recording and we will clean it up a little bit. We'll add a title slide, some of that stuff. Please email alumni@wabash.edu, and we can get you a copy of the recording. It'll be a YouTube link, basically, if you want to share this with some other folks. There will be a survey you'll get from me in the next couple days. Please fill it out. We've done this with all of our Whenever, Wherever Wabash events. It really helps us improve them, and we can compare them side by side. It's very short, very quick, so we would really appreciate that as well. Other Whenever, Wherever Wabash events, go to wabash.edu/www for Whenever, Wherever Wabash, and you will see live events on there that are coming up. You will see things for kids, coloring pages, podcasts, pre-made videos, and some other things on there. So take a look at that page, please. I think it's pretty phenomenal. So again, thank you, Dr. Schmitt. Really appreciate everybody being on, and be safe if you're traveling, and just have a good evening. Take care.
Thank you so much, everyone.